Hey there, welcome back to another installment of Why Math Why. And today we're going to talk about something that is probably being learned in some middle school classes around this time of year. Typically what people are learning all about is slope. And when they learn about slope, sometimes students just look at it as rise over run. Some people look at it as this formula, y2 minus y1 all over x2 minus x1, but sometimes we don't see the link between the two. So that's what I want to establish today, that these two things are not only connected, they are one and the same thing. So first things first, I've given a table of values right here, and we look at those values, and we see that there's a pattern with how x and y are connected. When we look at slope, just to remind you of what slope is, it's the rate at which, in this case, if we're just dealing with a standard function, a standard linear function that goes up at a constant rate, it's the rate at which y is changing as x changes. So if you look at it just right here, we've got minus 2 is the difference, and let me set that off with a different color here. You've got minus 2 is the difference here. Minus 2 is the difference between 3 and 1. Minus 2 again, we go down 2 from 1 to negative 1 and down 2 again. So we're going down in a y direction of 1, while at the same time we're increasing x as plus 1, plus 1, plus 1. So we can see the slope just from this is that y is going down 2 for every 1 that we go to the right. So that's a rise over run representation. Well, rise over run is also in the graph. If we plot two of these points, let's plot the points negative 2, 3. Right, so that point would be negative 2, 3. So that's right here. And then another point, I don't know, 0, negative 1. So that's down here. So if we take a look at this, and we look at the rise and the run, this is typically right here, the rise, whoop, and this right here is the run. And sorry, that's a little crooked. So a lot of students look at this and they say, okay, we've got this line right here, and that line goes from this point to that point right there. And they want to know, what is the steepness of that curve? Well, you could say, all right, well, I go down 1, 2, 3, 4, and to the right, 1, 2. So that's rise over run. And that's not so bad. Now, what does that really tell you? Well, that's telling you that for every 4 that we go in the down direction, we go to the right 2. Why does that matter? Well, that means that this is steeper than something that, let's say, goes down 1 to every right 1, but not quite as steep as something that goes down 3 for every right 1. So it's just a matter of steepness. That gets a little more advanced the more advanced math you get. What I want to show you now, though, is that this is the same as y2 minus y1 over x2 minus x1. If you look at these 2 points right here, if I subtract this point, and this point right here, again, is the point negative 2, 3, and this point down here is the point 0, comma 1. Sorry, 0, comma negative 1. Well, if you look at it, how much do we rise? Well, we're starting at a level of negative 1 down here. And we rise 1, 2, 3, 4. Well, what's another way of figuring out the difference between one point and another? So if I'm at position 3 here in the y direction and I want to go down to negative 1, how far apart are they? Well, that difference would be 3 minus negative 1. That would be how much space is between them. We subtract to find space. Well, that's y2 minus y1. This value minus that one. So that's also your rise. And then your run is the space that we go, right, from the left to the right here. And we're going left to right because we're starting at this point, just like we started at that point. So how much do we go? Well, 1, 2 to the right. Right? So if we think about it, actually, sorry, we started from here and went up. So I'm going to start from this point and go over. So we go 1, 2 to the left. So that's your negative 2 there, which will get you a negative. So if I want to figure out just how far apart things are, I'm at negative 2 right here. And then I'm over at 0. So I would subtract them. This is some position I'm at. Call it the marker negative 2. To 0 would be a total space of negative 2. So when I combine everything, I get 4 over negative 2, which is the same idea here. So the whole purpose of this is not to go over slope per se, but to show you that rise over run is identical. It is equivalent to y2 minus y1 over x2 minus x1. And again, many students will look at this and be like, yeah, I'll memorize this and I'll memorize that. But it's seeing the connections. between the table of values and the rate of change that we're going at, down to for every one we go over, how that corresponds with the graph, and how the graph also corresponds to this seemingly different formula, but it's all one big idea. All right, guys, I hope that was at least enlightening for some, if not a really cool review of where you've been. I'm stoked for the next video, whatever that's going to be. Haven't quite thought of it yet. Could be something related to slope, could be something completely off the grid, really in total. Either way, I hope that you're well. Much math to ya. Keep mathin' hard. See you next time. Peace.